Hey everyone, and welcome to another lesson of Azure Functions University. This time it's just me. Unfortunately, Gwyneth was ill. So Gwyneth, please get well soon so we can see you again on the next lesson. This time we're going to talk about storage queues. It's a lot of interesting stuff, both trigger-wise and binding-wise. So we'll quickly dive into that. Before we start with that, let me switch to this screen. If you want to follow along, please go to this repo. You can get this via this short URL. If this recording or stream goes too fast, you can follow everything in your own pace. If you go to this link, all the lessons are there. Source material is there. So it's quite a lot of stuff again for this lesson as well. And we have not only that, but we have also recordings and lessons for the HTTP trigger and also the blob trigger and bindings. So today it's going to be about the queue trigger and the output bindings. And the next lessons will be about deployments, table bindings, Cosmos DB bindings, and then a bit later on next year about durable functions and security. And I'm also going to do one about testing. So if you want to contribute to this content of Azure Functions University, please submit a content request. So we have some of them filed already. Gabriella is working on this one, on the Cosmos DB one. She already submitted the pull request, which I'm going to review soon. So if you find an interesting topic related to Azure Functions and you want to have a lesson about it, and you even want to co-author and co-host the lesson, please submit a content request issue. All right, so let's go to the lesson of today, the queue trigger and bindings. And yeah, before we actually start this, there are some prerequisites where we are going to use things related to storage. It's already mentioned last time, but this time you either need the Azure Storage Emulator or you need Azure Write if you want to develop completely locally. You can also still actually create an actual Azure Storage account, but I think it's nice that you can actually don't need to go to the to Azure, and you can just do it completely locally if you want, as long as you install and use the Azure Storage Emulator for Windows only, or Azure Write, which is cross-platform. So that's about storage emulation, so you don't need the real deal. And on top of that, we want to visualize what we have on our local development machines. And for that, you can use the Azure Storage Explorer. And that's a cross-platform tool. So you need only that, and then you're good to go. All right, let me get rid of this banner so you can see a bit more. So let's see what's in store for this lesson. So we have about 9 different topics. We're going to first talk briefly about the Storage Explorer, how to interact with queues. Then I show some different queue output bindings. Then I'll create a new queue triggered function from scratch. And then I'll briefly discuss the homework. So the Azure Storage Explorer for queues, I've attached some screenshots, but I can show it here live to you. So this is the Azure Storage Explorer. I've already am starting my local storage emulator that's running. So I can now visualize what's there. So I go to storage accounts, emulator. So I can expand this, and then we have queues. So if I expand that as well, I have a lot of queues. That's because I do a lot of things with durable functions, which use a lot of queues under the hood. So if you want, you can create your own queue right here. Create queue. I did it already a bit earlier. I created this new player items queue, and that's the one we're going to use during this lesson today. So I now click this queue, so I can now see the contents of the queue, and right now there's nothing in here, but there are some actions you can do to this queue. And right now, the only thing you can do is you can add, and apparently you can also clear the queue. There's nothing in the queue, but you can still clear it. But that means removing the content of the queue, and you can refresh it. So let's just add a quick message. This is one. So there are several options you can choose when you add a message through this UI. You can specify the encoding. By default, it's base 64. You can specify a time to live. So that means how long will this message be available in this queue. And by default, it will expire in 7 days. But you can change it if you want. You can also change the visibility. So when it's visible for clients which are monitoring the queue. If you have it at 0, then they remain visible as long as they are in the queue. So let's hit OK. And now we have added one message to the queue. So notice that every queue message has an ID. So we didn't specify this ID, we only specified the message text. But if we double click it now, we open the message and we see it has some additional properties. So we have an ID and we have an insertion time. So that's when I click the button add it. So it's been added to the queue at this timestamp. And then here's the timestamp when it actually expires. And so this is 7 days later. The DQ count, that's a count how many times a client tried to get the message from the queue and process it. But in case it fails to process it, it might try again to read it from the queue and try to process it. So in case that process is going on, it tries to dequeue it. But if the processing fails, it puts it back. So then we have a dequeue count of 1, and then it can continue a couple of times. We'll come back to this later when we actually create a queue triggered function. So there is some additional metadata when you have queue messages. So let's add another one. Message 2. And message 3. Right, so now we have these messages all in order. But unlike blobs, you cannot now delete message 3. So if I hit the delete button, it can't be deleted. Also, if you hit this DQ button, it will DQ a message, but that message is not the message you've highlighted here, because the queue has this concept of what comes in first also goes out first. So first in, first out. And that's true for most of the times for general storage queues, but it's not guaranteed to be first in, first out. If you want that guarantee, you need to use the service bus queues instead of the Azure storage queues. But what happens if I dequeue a message now? So now I have message 1, 2, 3. So if I dequeue a message, it asks, are you sure you want to dequeue the first message in the queue? So yes. So then message 1 is gone because that message was the oldest one. So that will be removed first. So, and again for this one. And again for this one. So that's important to realize. You put messages in a certain order. And it always tries to remove the message that has been in that order first. Although again, the order and the first in, first out is not 100% guaranteed when you use Azure Storage queues. That can be guaranteed when you use Service Bus queues. The other options are that you can requeue a message. So it actually duplicates the message. So it's added again to the queue. And you can also move messages between queues. And clear queue, like I said, it removes everything from the queue. That's about the Azure Storage Explorer and how you can interact with it to add and remove messages. I didn't explain yet what the actual use of storage queues in combination with Azure Functions are because queues are really quite powerful way to decouple applications. For instance, you can have a web application that has a public-facing website, and maybe that contains also some processing capabilities. Maybe you have a kind of a web shop. People can browse for products, and then they can also put orders on your website, and you have the whole payment process and stuff like that. So you could decide to have all that functionality within one web application, but you can also decide to move that responsibility of managing orders and managing the payment process in different applications. And one way to break that responsibility from one application into different applications is to use queues. So you can go from your web application, and then when a client wants to, a customer wants to order a product, and then a message can be put on a queue, and then another application like a Azure function can read that from the queue and can do further processing. So it's quite a relatively easy way to break up larger systems into smaller systems. So I use it quite a lot. All right. So let's actually do some demos about the queue output bindings. So we'll have a few examples where we work with an HTTP triggered function. So an object comes in, we use a post message, but as a result of that function, we put that message that we receive from a post, we put that on a queue. And there are different ways to do that. So the first one uses a string queue output. And I've already prepared some demos here, so I don't have to code everything from scratch. If you go to the repo, you'll see all the samples there. So it's under source, and then it's under Azure Function Queue. And there we have the output folder. And then there are 5 different functions, which each use a different way of putting a message on the queue. So I've now selected the first one. We're going to discuss how to use a simple string return type. So this is really the most basic example you can get. We have this function name, new player with string queue output, it's called. And what we see here is that we use the return attribute of the queue. And we saw a similar return attribute, I think, also with blob storage. But the only thing we specify here is, okay, we want to return something, we want to put something on a queue, and then what's in this queue attribute is then the name of the queue. And in this case, I created a class, and that class contains the name of the queue, so the new player items. That's just to make sure that I can refer to that string very easily. Instead of having strings all over the place, and if I need to change the queue name, I have to change it in five different places, and now I only need to change it in one place. Another great place is to put that queue name in your application settings. So the only thing that the queue attribute requires is the name of the queue. Another thing that you might need is a connection to the storage account. And when you provide that connection, this is the same as for the blob trigger. You don't specify the complete connection string here, but you refer to an application setting, and that application setting contains the connection string. So if we look to my local settings, so my local settings, I do have a separate application setting for storage, which is in this case my emulated storage, because this is a special connection string for emulated storage. So I can put that in here. So now I've made it explicit that I'm using this specific storage account to put my queue message on. But again, if I remove it, just like I had, like this, then it will fall back to the Azure Web Job Storage connection. And so that's the storage account that the function app itself is also using for its files. So whenever you don't specify it, it will use the storage of the function app. Well, then we have an HTTP trigger. It will do a post. We have the player object again, which was also used in the blob example. So we have an ID of a player, we have a nickname, an email, and a region. We receive a player object, and the only thing we do is we turn it into a string, and that is immediately put on the queue. So let's start this app, and let's do this. So to test it, I'm using the REST client in VS Code. I have an HTTP file that's also in the repo, so I can make HTTP calls directly from this this HTTP file. So I think everything should be started. Yeah, I think it should be running. So let's call this first endpoint of the new player with string queue output. We provide a player object, and then we should see a message popping up in this queue. Okay, let's run it. So we get back a 200 OK. That's because I'm using the HTTP trigger, but I am not controlling actually the output of the HTTP, because we use this return queue attribute. So it will by default will give back a 200 OK. So now let's go to our storage queue. So it appears that nothing is there, but we just need to refresh it. And here we go. Here we have our queue item. Data is there. Cool. So that worked. D3. So yeah, so that's the most basic example you can get. Let's move a bit further. What is good to know is that I added a NuGet package to this project, which you might not actually still need for this sample, because I think this queue attribute is still part of Azure Web Jobs. Yeah, so you don't need it right now. I'll come back to it later, what packages I've added for this one. Let's go to the next example, which uses a different type for the output. Oh, no, I skipped over it. Oh no, it's all right. Yeah, so now we're using a custom output type for putting a message on the queue. So there's this function. So we have this exactly the same HTTP trigger as before. A player method comes in via a post, but now we have this output binding specified directly under the HTTP trigger. So it's part of the run method arguments now. We use the same queue name in the queue attribute, but now we have specified that we're going to use a player as the output parameter. And since we are not using the return attribute here, we have a bit more control over what we give back to the client. So I'm now doing a bit of a validation of the player object. So in case the player ID is null or empty, I give back a bad request. And if that ID is not null or empty, then I set the output player object to be equal to the input player object, and then I give back an 202 accepted result. So let's run this. Go to my HTTP file again. So this is the new player with typed queue output. So let's run this. So I get back a 202 accepted, which means that the player, in this case Grace, should now be also in this queue. So let's have a look. Let's refresh this. And indeed, there we go. We have a new message here. And what's interesting that we also have some kind of a property added to it, kind of a metadata property in this case, and that only happens when you use this type of output binding. All right, so that worked. Let's move on to the next example, and that's by using a CloudQueueMessage type. So that's one of the types from Azure itself. So that's this one. And this CloudQueueMessage, that is not available in the normal web jobs namespace that you have available when you create an Azure function. So this type actually lives in a different namespace and also in a different NuGet package. So if I click on this type, we'll see that it comes from a Microsoft Azure Storage Queue.dll. So you have to actually be aware that you need a dependency to this different NuGet package. So now I close the file. Here now using this one. So you can see in my projects file that we have added this NuGet package of Azure.storage.queues. And it's quite important that you use this one because there are actually older versions, but not an older version, older packages with different names that also contain that same CloudQueueMessage type. But please don't use that. You should use the Azure.storage.queues in this case. That is the only correct one. It's a bit unfortunate that the same type is available in different packages. It has a bit of a long history. I see a question. Where's Gwyn? Gwyn is ill, unfortunately, so I have to do it on my own. I think she'll be with me again next time when we do a new session. Okay, so we added a reference to this package, the Azure.storage.queues. And so now we can use this as our output type. And the rest is more or less the same. So again, we do this check if the player ID is null empty, we give back the bad request. But if it's not, then we serialize our object because we have a player object. So we have a string, and we create a new instance of the CloudQueueMessage because the CloudQueueMessage either accepts a string or a byte array, and that's it. So in this case, I'm just serializing my object. And since I've assigned it here, that's enough because it's an output message, and I give back a 202 accepted result. So let's run this one. So that's this one, the CloudQueueMessage output, in this case with Ada. Let's run it. Now we get back a 202 accepted. So that means a new message should appear underneath here again. Yeah, exactly. All right. So yeah, and be very aware which NuGet package you use when you use this CloudQueueMessage type. The next example is using dynamic output bindings. Well, if you've watched the previous lesson about blob storage, we also used dynamic output bindings there as well. So they're really powerful feature because you can decide during runtime what the actual attribute and the parameters of the attribute will be instead of at compile time. So in this case, I again have the HTTP trigger, same as before, but we don't have a specific binding defined in the method itself, in the method definition itself. So we just have an interface, iBinder, and we actually go to set up the actual binding inside the method here. And how I dealt with it here is that based on the validity of the player object, I will define what the queue new name is, where I'm placing the message to. So if the player ID field is null or empty, then I'm using a queue called new player error items. So I still want to capture the information and put it on a queue because some other department might still want to know what are the messages that come in, but we can't handle automatically, or maybe there's still some valid information in there that we can use. So I'm not throwing the message away. I still want to keep them for inspection. So then I'm using this specific error items queue. But if the player ID is there, then I'm using the queue, regular queue as before, the new player items. So based on the validity of the player object, I define the queue name. Then I serialize my player object again. I use the same type of message as before, the CloudQueueMessage. So again, from the Azure.storage.queue type, and I wrote down here explicitly, not the old Windows Azure Storage Queue. That's the older reference to it. I create a new queue attribute. I pass in the queue name. And then we do a bind async of type cloud queue. And so I want an instance of a cloud queue that receives the queue attribute. And that cloud queue type, that has several methods, but I'm using the add message async method. So I'm now adding a message to this cloud queue. And what I'm passing is the cloud queue message we've defined here. And then we return the result, which is if it succeeds, and the accepted result, and if it fails, a bad request result. So let's run this as well. So let's do 2 tests. Let's do one test where we pass the ID, and let's do one test where we don't pass the ID, because we should verify if it gets sent to either of the queues. So let's first do a valid message. It's again with Ada. So we get a true or true accepted. So now it should appear on our new player items queue. So there should be a 4th message now. And yes, indeed, that works. But now let's do the other one. So let's remove this, and now post this. Note that I don't have already created a queue called new player error items, but it will be created automatically for me. So let's do it now, and it will be placed on another queue. So we do get back a bad request, which is as we specified, but the message should still be placed on the queue, but then the different queue, the error items queue. You don't see it here by default, but if you refresh this, and then we have to expand our queues again. Now there should be indeed a new player error items, and that indeed contains our message, now with a null field for our ID. So that works as well. All right. So there's one left, and that is the IAsyncCollector output binding for queues. So that's really a new concept. We didn't have that with the blob. So what happens here is this one. So this IAsyncCollector output binding is really useful when you don't have just one message you would want to put on a queue, but you have several messages you will want to put on a queue. So in this case, I have an HTTP trigger, and that expects an array of player items. So not just one, but a collection of player items. what I want to do then is for each of the items in that array, I want to put that message on the queue. But that won't work if you just specify the CloudQueueMessage here or use the output arguments. For that purpose, there is this IAsyncCollector type or interface in this case. And how that works, this will create an in-memory object for you, this collector object, and you can add your items. In this case, you can do it strongly typed. So I'm adding player items to this in-memory object. And once I'm done, and once this function is done, it will flush this collector object to the queue. So first I'm adding the items to the collector, and so that then they are not yet added to the queue itself. They are only added to the queue when the function is completed, or when you actually call collector.flush async, because you can also flush explicitly, but it also do it by default when the function is completed. So what's happening in the code? We first check from are there any players to process? And if not, I return a bad request result. But if there are players, I iterate over them, I add them to my collector, and then I don't have to do anything with the collector anymore, because, like I said, the flushing will be done by default. So I just return the result. So this is the endpoint we're going to hit, and then I'm passing in an array of 3 players. So let's call this. I've put a breakpoint here so you can actually see it happening. So this is the first time it adds to the collector, and then the second time and the third time, and now it should be done. And we get a 202 accepted back. So now let's go back to our new player items, and it indeed contains 3 new messages. So that also worked. So this collector pattern, that this collector item is really useful to apply when you want to do a bit more work than just put a one-on-one message on just one queue. You can put multiple messages on the queue. Quite easy. Okay, let's stop running our application. So that's are all the different output bindings and the types you can use. What we can do now is actually create a queue triggered function, because right now we've only used HTTP triggered functions and put something on the queue. But the nice thing about Azure Functions is that they can also be triggered when something is put on the queue. So they can respond to a queue. So I have a new instance here of VS Code. So let me create a new function app. I'm going to create a new project, Azure Functions. And this is the correct location. So that's correct. I'm going to select C# as my language. Our template will be a queue trigger. Let's use the hello world sample. So this will be the name of the trigger. And I have to specify a namespace. So let's stay true to what we have written down here in the documentation. We'll ask from, okay, do you want to create a new local app setting? And that's what we definitely want to do. Since this has to do with storage, it now is asking, okay, select a subscription for storage. So let me select this subscription. And I already have a storage account which I created previously for the blob lesson, so I'm going to reuse that. Otherwise, you can also create a new storage account in Azure. And then you have to specify the name of the queue. In this case, we can leave it as it is. It can be anything you like. Then it will ask, okay, in order to debug, you must select a storage account for internal use by the Azure Functions runtime. So that's the Azure Functions web storage. I'm going to select local emulator because I am just running it locally anyway. I want to open this in my current window, please. So now it's creating the project, creating the queue trigger. So let's have a look what this will create for us. Okay, let's get rid of this. So we have our project. Let's have a look, and there's the thing that's added there is, okay, so it's a functions project, but it's also now using a webjobs extensions.storage NuGet package because we are dealing with one of the storage types, which is queues. So that's the additional dependency you have when you create this this function type. Let's first go to our actual queue trigger. Let me put in a few line breaks because it's quite long. So we have our static class, our function name attribute, our run method, and in that method there is a queue trigger now specified. And the queue trigger has two arguments. The first one is the queue name, so it's the my queue items which we specified, and the other is the link to the connection. And like I said earlier in this lesson, and this connection is not the connection string directly. This is a reference to an application setting with this name, and this application setting has the storage connection string. So then we specify how we can access this message. So in this case, we're just using a string type message. It's called my queue item, and we also have access to a logger. And then the only thing the template does is just log something to the output and actually reads the message and puts it in the console logger. So let's have a look what it actually uses now as this AZfuncStore_storage setting. So if you go to our local settings JSON, so this value, the AZfuncStore_storage, that has the connection string to the Azure Storage account. But since I like to run everything locally, I'm not going to use this storage account. What I'm going to use is actually the same storage as Azure Functions is using, and that's the local storage emulator. So that's why I like to specify this use development storage is true. So now when I want to run it, it doesn't use Azure at all. It runs completely locally as long as you have this storage emulator running. What I also can do is I can also remove this connection now because it refers to the same storage anyway. So this will now also work. So let's run it now. So this message will not be triggered now. Only it will be triggered when we put an actual message in this my queue items queue. So that's what we have to do now. So it recognized that there is a new queue trigger. It's the hello world queue trigger. It's completely up and running. I've put a breakpoint in here. So what we can do now is put a message in there in the my queue items, and then we should see this triggering. So let's go to our Azure Storage Explorer, and I already created the queue up front. So this is the queue. So now let's add a message. And I press OK, then we should hit the breakpoint. Yep. So we can see the message is still here. But once this function is completed, it will be gone. So we can see that the breakpoint is hitting. We can also see the content of this of the message. That's hello world. So if we continue, we will also see that it has logged here to the output, hello world. So that's also working. And now the message should not be here anymore. So it looks like it's still there, but if we refresh it, it should be gone because the processing of the message was successful. So that means the message is dequeued and it's not there anymore. There is also a situation where the processing might not be successful. So what happens then? So there's a very nice built-in feature when it comes to queues. When the client cannot process the message correctly, it will retry a couple of times. By default, it will retry it 5 times. So maybe you can remember the DQ count on a message. If you go to an actual message here, this DQ count. So if a processing fails, it will retry a couple of times until this DQ count reaches 5. And if it still cannot be processed, then it will put the message on a so-called poison queue. And so that's built-in behavior in storage queues and also in service bus queues. It will actually create a new queue, which has the same name as this queue, but then it will have the postfix -poison. So let's actually try that. So how can we enforce that? Well, we can actually, let's stop this function. And instead of logging, we'll throw an exception. So by throwing the exception, that means Azure Functions will try to dequeue the message, or it will dequeue it and it will try to process it, but the processing will fail because there will be an exception. So it will try to dequeue it, and it will try that a couple of times until it has reached the 5th time, and then it will give up, and then it will put it on a poison queue. So let's try this. Let's run this. So I put a breakpoint here so we can monitor the process. It's building, it's starting the local Azure Functions runtime now. Okay, it's up and running. So let's put in a message, and this will fail. This will fail. Okay, it's being picked up. So let's now step over this. Okay, so we have an error, right? So now we can continue. So I'm not sure if let me actually refresh this now. Yeah, so it's being picked up. It's still processing, but let's continue now. Okay, so now it's being triggered again. So if you refresh this. Okay, we don't see it, but that's because it's still processing. Okay, so this is the 2nd time now. Let's start it. Again, it fails. So this is the 3rd time, and the 4th time, and now the 5th time. So this should be the final time. Yeah, so now it won't be processed anymore, and we also see it actually in the output here. Message has reached max DQ count of 5. Moving message to queue, my queue items minus poison. Okay, so let's go back here. I was hoping to inspect the message here and to see the DQ count incrementing, but that's not possible. But what it actually did happen. So let's go to the poison queue now, which is created for us. So we have a my queue items poison, and that indeed has our message. So that's, it's very important to know that this behavior is built in, because maybe if you don't know it, you might want to try to make your own retry functionality or portion queue handling. But this is already out of the box functionality for storage queues. So that's very nice. What you do have to take into account is that you have to monitor this portion queue, because in case things go wrong, items will be removed from your regular queue. But in case you're not monitoring your portion queue, then you might think everything is still going all right. So whenever you are working with queues, also make sure you monitor your portion queues. There's one additional thing I did not mention yet, and that's about the content of the host JSON. Because I mentioned by default, it will there is a certain behavior that a queue-triggered function will do, like the dequeue count, things like that. But you can actually override some of that default behavior. Let me open this link to documentation. So you can actually override the queue-specific behavior in the host.json. Let me make it a bit bigger. So the host.json, by default, when you create your template, it's quite empty. It just contains a version of the schema, and it contains a bit of logging. But this host.json can be extended in quite a bit. And one of the things you can specify related to queues is, for instance, the max dequeue count, which we've seen before. And so by default, it is 5. But if you just want to dequeue maybe just 2 times for trying, then you can set it lower. Or maybe you think, okay, maybe my other processes in my Azure functions are maybe a bit brittle, and I need a lot of possible retries. Well, then you can maybe set it to 10. So you can tweak these numbers. The batch size, that has to do with how many messages will be processed in parallel. So because now you're just reading just one queue of message, but your queue could contain thousands of messages, and then Azure function will try to process them in parallel, and then it will scale out. So I think by default in it is set to 16, the batch size, and so it will try to read or to process 16 messages in parallel. Another thing that's important to know is that when you are using queue-triggered functions, that Azure Functions is actually doing some polling to that queue, and you can actually change the frequency of the polling. And so right now it checks every 2 seconds if there are new messages, but you can indeed increase or decrease that. And what you can also change is the how long messages will be visible on the queue. So there's some quite everything is documented. It contains some good information, also some good guidelines. So definitely you need to take a look there. I mean, when you're just getting started, it's fine to use the default and just play with it. But when you're ready for a production workload, then it's really useful to look into these numbers and to see if they're actually correct. All right, then I think it's time for the homework. So I've come up with a small homework example where you write a queue-triggered function, and it listens to a accomplishments items queue, and you can put accomplishments objects on there, and an accomplishment is like maybe a certificate you achieved, or an online course you completed, or a coding project you put online. So you can, for instance, you have a title, I have new online course. I completed it, so there's a title, I have a date of completion, and maybe you have a link to the course you completed. So that could be your accomplishment object. So the function you can write the homework will then listen to this accomplishments items queue. You can use it as a strongly typed message, and what it then can do is then you output that accomplishment as a JSON blob. So I think this is a nice homework example. If you done lesson 2 for blobs, and now with lesson 3 queues, then you combine them both. If you want to read more about the storage queue and bindings, there's quite a bit of documentation on the official Azure documentation site as well about it. I've covered quite a lot, but yeah, the documentation is quite extensive and quite good. Again, if you may be using a different language, then there's also samples in different languages as well. So please have a look if you are interested in more of the queue triggers and queue bindings. All right, that's it for this evening. Let me know indeed if you have any questions, or please let us know if you have done some earlier homework or this homework. Tweet about it on Twitter and use the hashtag Azure Functions University, and then we will feature your homework assignment in the next show. It will probably be in about 2 weeks, and we will talk about deployments then. Yeah, we'll see. Maybe we'll take some time off at the end of December. I'm not sure yet, so maybe this one will be postponed to January. But we'll definitely do one this year still. So thanks for your attention, and until then.